Okay, so now we will solve question number 1.8 NCERT class 11 physics. So we will solve one by one. Let us see question number 1 first. Question number A, it's telling you are given a thread and a meter scale. How will you estimate the diameter of the thread? So what is thread here? The thread is something like wire. Okay, I will just paste a picture here. Just try to understand this. You can think that you have to find the diameter of the wire. That's it. Okay, so it's very simple, isn't it? Now see, suppose this is a wire and the wire has been wrapped around the cylinder. The cylinder may be hollow or solid, it doesn't matter. There shouldn't be any gap between two consecutive wrappings. Now just see, for one turn, this is for one turn, in one turn you can easily see that the diameter of the wire will cover. For 2 turn, 2D will cover. For 3 turn, 3D will cover. Now with a scale, it is very difficult to measure one turn, isn't it? Because the least count of the scale is what? 1 millimeter. So it is very difficult to measure with a scale. It's very difficult to measure one turn with a scale. So what you have to do is, you have to wrap the wire around the cylinder and you have to measure this length. You have to measure this length. Okay, and you have to consider that there shouldn't be any gap between two consecutive wrapping. Okay, so if you find that this total length is L and total number of turn is N, then definitely the diameter will be equal to L divided by N. Okay, so now I will write the answer here. Okay, I will write the answer here. So the first step is to wrap the thread. Thread is nothing but wire. Okay, wrap the thread around the cylinder. Not B, 1 minute. Then measure the length covered. And the number of turn. If length is equal to L and numbers of turn is N, then dia will be equal to L by N. That's it. This is question number 1. Hope you have understood. Now let us solve question number 2. See, it is telling a screw gauge has a pitch of 1 millimeter and 200 divisions on the circular scale. Do you think it's possible to increase the accuracy of the screw gauge arbitrarily by increasing the number of divisions on the circular scale? So it is telling that the pitch is 1 millimeter and total division is 200 in this case. So what will be the least count, you tell me? The least count will be 1 divided by 200, this millimeter, isn't it? Now the least count is related to accuracy. Okay, if the least count decreases, suppose the least count is very very small, then the instrument is highly accurate. Okay, that means the accuracy is better. So in the question they are asking that arbitrarily by increasing the number of division, is it possible to increase the accuracy? Okay, so you can see that if the number of division increases, what we know, number in question B I will write that the least count is equal to pitch by division, isn't it? Now you see, division increases. If division increases, that implies that this least count decreases. That means the accuracy will increase, isn't it? So accuracy will increase. So it's possible, theoretically it's possible. So if I increase number of division, then accuracy will definitely increase. Theoretically it is possible, but in practical situation it's something different. Why? You see, suppose you have made this number of divisions 1 lakh, okay, arbitrarily, then what will happen? Then you just tell me one thing, the corresponding to the rotational motion of the screw gauge, there is one corresponding linear movement, isn't it? So in that case, if you make the number of division 1 lakh, in that case what will happen is linear movement, increment in linear movement will be very very small, isn't it? So practically it is very difficult to manufacture those instruments, and it's difficult to maintain those instruments also. And for human also, for measurement, human eye also will not be able to measure perfectly. So practically it's really very difficult, though theoretically it's possible. So the answer will be theoretically it's possible. So I will write possible theoretically, but difficult practically. Okay, but difficult practically. That's it. This is question number B. Now let us see question number C. It's telling the mean diameter of a thin brass rod is to be measured by vernier calipers. Okay. Why is a set of 100 measurement of this diameter expected to yield more reliable estimate than a set of 5 measurements only? So they are telling that 100 measurements is more reliable than 5 measurement. Why? This is the question. Randomly they are taking the measurement. Okay, suppose you are doing a measurement randomly. How you will do the measurement? You will take measurement repeatedly, you will do measurement. So if you take 100 measurement, you will take the average of those measurements and you will get a value. In the second case, suppose you are doing 5 measurements and you are taking the average, then you will get one more value. The second value is less reliable. Why? That we have to think. Okay, now you see, randomly you are measuring, and here they are telling about reliability. About reliability, that means the probability will come into picture. That means we have to think about random error. Okay, so random error is something, if standard deviation increase, then random error also increase. If standard deviation decreases, then random error also decreases. Okay, so what is standard deviation? Let me tell you. Before understanding standard deviation, suppose you are doing n number of measurement. Suppose this is first measurement, x2 is the second measurement, and like this you have done total n measurement, you are doing the average. Now the average is denoted by x bar, that will be equal to x1 plus x2 plus xn divided by n, that will be average. Now this x1 minus x var, that will be the deviation for x1. So I will write this d1, deviation for x1. So deviation of x2 will be x2 minus x bar. That means how much x1 is deviated from the mean value. Now if you do the square, of all this deviation, that means if you do, suppose you are not doing a square, what will happen? If you do d1 plus d2 plus d3 plus like this, if you are doing dn, then do you know you will get 0. That's why they square the value. So if you do the square, okay, if you do d1 square plus d2 square plus like dn square divided by n, a root, that's nothing but standard deviation. Okay, now we can see that n is in the denominator. So n is number of reading, isn't it? N is number of reading. Okay, so if n increase, then what will happen? The standard deviation will decrease. Then what will happen? The random error will decrease. Okay, so if n is 100, then definitely it will be more reliable because n is in the denominator. Hope you have understood.